To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So, my dear children, in the earlier chapter, we discussed several theoretical parts related to the density lesson, and we deduced several units to measure the density. Within this chapter, we'll be mainly discussing how to compare the densities of different liquids. Here especially, we are going to use several common liquids that we can find, and we are going to compare their densities by using several calculations. So here we are going to find out the density by using the mass upon volume ratio. Okay, right. So here the solutions that we need are given within the diagrams. So we'll be using, first of all, a common salt solution, normal water, then coconut oil, right? So we'll be using these three substances to measure the density. Okay, we'll be using these three substances to measure the density. So let's write down the contents, my dear children. We'll be needing these liquids, then water, salt solution, then coconut oil. The three solutions that we need, okay, the three liquids. Then, my dear children, we'll be needing a measuring cylinder. Measuring cylinder. We'll be needing a measuring cylinder. Then a beaker. Then a beaker. Then to measure the masses, we'll be needing a triple beam balance. Right? To measure the mass, we'll be needing a triple beam balance. So measuring cylinder, beaker, water, coconut oil, salt solution, then the triple beam balance. So these are the materials that we need, my dear children. Now let's head on to see how to conduct the activity. Right. Clean and dry the beaker of 250 milliliters and measure the mass of it. So here the beaker that we are going to use is 250 milliliters. If you want, you can use even greater than that. But however, it's probable to use 250 milliliter one. Okay, or else somewhat lesser or greater one is also fine, no problem. So clean and dry the beaker 250 milliliters and measure the mass of it using the triple beam balance. So first of all, you have to measure the mass of the empty beaker. Mass of the empty beaker. Measure 250 milliliters of water by using the measuring cylinder of 250 milliliters. Then put into the beaker. Measure the mass of the beaker with water. Now what do you have to do, my dear children? Like in the previous activity, where we conducted the activity by using different volumes, and we measured the masses related to those things. Now within this activity also we'll be doing the same thing, but however, we are using three different liquids and we'll be using only one particular volume. So that volume is, my dear children, 250 milliliters. So you have to measure 250 milliliters by using the measuring cylinder. Okay, you have to measure 250 milliliters of water using the measuring cylinder first. Then you have to insert that water content to the beaker. Okay, you have to insert that water to the beaker. Okay, we measured the empty beaker earlier. Now we are going to measure the mass of beaker with water. Okay, so measure 250 milliliters of water using the measuring cylinder of 250 milliliters. Then put into the beaker. using the mass of beaker, so measure the mass of beaker with water. So then we have to measure the mass of the beaker with water. Then by subtracting, you know that we can find out the mass of water, like in the previous case, okay? No problem. Then what do you have to do? Remove water and measure 250 milliliters of concentrated salt solution. Concentrated means here we are going to dissolve somewhat more salt, my dear children. That means there are more salt particles. Okay, like concentrated means here you have to dissolve somewhat more salt. More salt means in the sense maximum possible amount of salt which you can dissolve should be there. Okay, so you take like 20 grams, you dissolve up to a maximum level, you dissolve, then you can even filter and take the solution. Okay, right. So concentrated salt solution is our next one. So we have to measure 250 milliliters of concentrated salt solution, then put into the beaker. Measure the mass of beaker with salt solution. Now what you have to do with the salt solution, you have to measure the mass. Okay, then in the same way, measure 250 milliliters of coconut oil and measure the mass. So in the same way, you have to measure the mass of 250 milliliters of coconut oil as well. Here a special note is given. Note that the beaker and the measuring cylinder should be well cleaned and dried before measuring the coconut oil. Tabulate your readings and work out the calculations. Then you have to tabulate the readings and work out the calculations. So to get the calculations, once again you are given with a table, my dear children, right? First of all, you mention the mass of the empty beaker. Then the solution which you have used. Then the volume of that solution. You know that the volume is constant. We took 250 milliliters or else 250 cubic centimeters. You know that 1 ml is equal to 1 cubic centimeters. Okay. Then mass of the beaker with the solution. How much is the mass of the beaker with the solution? Then the mass of the liquid. Okay. By subtracting, you can find out that. Like in the previous activity, my dear children, which we did within the first chapter. Okay. Then you have to find out the volume over mass over volume scale. So here, my dear children, there is a small bit of a mistake. Within your textbook also there is a mistake. Here it is given as volume and scale thing. But the correct one should be mass over volume, right? Mass over volume scale. Okay. So we'll recorrect that thing. So we'll recorrect. So mass M volume. Mass over volume. Right. So this is the table that you need to complete by doing the activity. Okay. Right then, my dear children. Now let's head on to the laboratory. We'll take 3 of these each and we'll measure their masses separately by using the beaker. Then once again we'll come into the classroom. Then we'll calculate our densities of the liquids by using the table which is over here. Right then, so let's head on to the laboratory, my dear children, and we'll conduct the activity. Right, my dear children. Now within this activity, I'm going to measure several masses of several liquids. Actually, I'm going to take 250 milliliters of different kinds of solutions. So especially we are using 3 kinds of solutions over here, liquids. These 3 liquids are pure water, then secondly salt solution, and 250 milliliters of coconut oil. So we're going to measure first of all the mass of this empty beaker. As you can see here, 250 can be observed. So I'll place this thing. Before that, check the reading, my dear children, whether it is getting tallied or not. Yes, exactly, the 2 lines are getting tallied each other. So let's keep the beaker over here. Right, so before, now my dear children, before you are going to enter water in or any kind of a solution into the system, first of all you have to measure the mass of this beaker, right? So now I have kept the beaker over here, so let's measure the mass first. Let's take this 10 to the 100 first. It's less than 100 then. So we'll keep this thing over here and we'll take the 10 gram weight towards right. Okay. Now the smaller one. Right, so I have measured the mass of the empty beaker, my dear children. 10 gram one is at 70, 100 gram one is at 0. Here, this one is at 2.5. So, altogether 72.5. This is the empty beaker. Mass of the empty beaker is 72.5 grams. 72.5 grams is the mass of the empty beaker. Now what I'm going to do is I'm going to take this volumetric flask of 250 milliliters. Okay. And I'm going to pour water into this and I'm going to measure 250 milliliters of water. So like in the previous, when I measure in smaller quantities, I'm going to use the dropper. Always keep the volumetric flask at your eye level. Right then, 250 milliliters of water. Right? 250 milliliters of water, my dear children. Now, as you can see here, this is the mass of empty beaker. Now, I'm going to insert this 250 milliliters of water into the beaker. And let's check the mass. Right. So here we go then. Now we are going to measure the mass of this beaker which contains water. Right, water is filled up to 250 milliliters. Right, so let's check how much is the mass of this 250 milliliters of water. Right, so here we go then. The two lines are getting tallied each other. The heavier mass is at 300. Next one, 10 by 1 is at 10. And here this one is at 9.6. So 319.6 is the answer. 319.6. Okay, 319.6 is the mass of 250 milliliters of water with the beaker itself. Okay, right. So let's take this thing once again. Pour down this into the container once more. Now I'm going to measure. Let's keep it over here. And now I'm going to measure 250 milliliters of salt solution. Okay, so let's take a salt solution and we'll measure it. Right, my dear children, this is the second solution, common salt solution. So let's take 250 milliliters of common salt now. 250 common salt. Okay, let's see. I can add like few drops. Right. Now let's take the dropper once more and we'll use the dropper to put the extra ones. Right. Okay, my dear children, here we go. 250 milliliters of sodium chloride solution, common salt. Okay, 250 milliliters of common salt solution. Right, so let's add this thing to the beaker once more and we'll measure how much is the mass. Right, now let's measure the mass, my dear children. So Right. So the larger mass, heavier one is at 300. The second mass is at 20, 320. And over here, it's 9.2. Right. Here it is at 9.2. So 329.2. 320. So here 320 and 9.2. 329.2 is the answer for the 250 milliliters of common salt solution with the beaker, my dear children. Okay, the mass of 250 milliliters of common salt with the beaker. 329.5. 329.2. 329.2. Right. Okay, now let's head on to measure the mass of coconut oil, 250 milliliters. Okay, but remember, when you are inserting coconut oil into this beaker, make sure this thing is pretty much dry, right? Otherwise your values will get faulty. Okay, so you pour this thing down and you have to clean it. You have to clean the beaker very well before entering coconut oil into the system. Okay, right then. So we'll measure 250 milliliters of coconut oil in our third step. Right, then I have with me coconut oil, my dear children. So as you can see here, now the beaker is also dry and the volumetric flask is also dry. Okay, so remember to dry these things out before you are going to measure the volume of 250. Okay, now let's add and get the 250. Right, so coconut oil layer is somewhat hard to find, so you have to keep your eyes somewhat closer to the level, right, of the 250. And also with the air bubbles coming out from the coconut oil solution, my dear children, it's somewhat difficult to measure 250, but however now I don't think that you could observe the 250 level very clearly, but however I know that I have measured it very clearly. So you have to keep it somewhat closer rather than the water, right? You won't be able to see it very clearly, but for the naked eye it's very clearly visible. Okay, so this is 250 milliliters of coconut oil. Now I'm going to pour this thing into the beaker once more and let's observe the mass. As the coconut oil is having some amount of a viscosity, I mean like if you take the viscosity, so it's somewhat denser, that's why it is having a heavier viscosity. Actually denser in the sense somewhat thick. Okay, density is not that much high, but however it is somewhat thick, my dear children. The viscosity is somewhat high. It is referred as the viscosity. Okay, right. So try to add each and every drop into the system. Right then. So here we go then. Now let's measure the mass of it. Right. So this is the third solution, my dear children. Third and the final solution, coconut oil, 250 milliliters of coconut oil. Let's see how much is the mass of it. Here this is at 200. Here this is at 90. Here 8.2. So altogether 280, 290, 80 here 90, 298.2, 298.2, right? 298.2 is the mass of coconut oil with the beaker, right? 250 milliliters of coconut oil with the beaker, mass is 298.2, right? So these are the masses of different solutions, my dear children. We measured the mass of 250 milliliters of water and 250 milliliters of coconut oil and also 250 milliliters of common salt solution. Now let's head on to the classroom and we'll tabulate our readings. Right, my dear children. So we have conducted the activity. Now it's time to tabulate our readings, my dear children. So first of all, we are going to take the mass of empty beaker. So as I think you have over there, you have looked at the looked at the scales, my dear children. I hope that you have noted down them. So you know that the mass of empty beaker was equal to 72.5 grams. So we'll mention here 72.5 grams. This is the mass of the empty beaker, mass of the empty beaker. Then the first one is, right, first liquid that we took is water. So water, how much is the volume, my dear children? We took 250 milliliters, 250. Then second one is salt solution. Second one is salt. Then final one, coconut oil. Coconut oil was the third one. So 250 is the volume that we took in each instance. Now the mass. So the mass of, right, the mass of first one is, we measured the mass, my dear children. It was 319.6. 319.6. Then the second one. 329.2. 329.2 was the second one. Then, my dear children, the third one. 298.2. 298.2 was the third one. So, first one was 319.6. Second one 329.2. 329.2. Then the third one 298.2. Third one is 298.2. So, these are the three masses of the beaker with the liquid. Then the mass of the liquid, my dear children. So, to find out the mass of the liquid in the first instance, what we have to do? You take 319.6 and you subtract that 72.5. You have to subtract 72.5. Then here 1, here 7. 31 minus 7 is 24. Right? 1, 7, 31 minus 7 is 24. So, 247.1. 247.1. Then the second one. 329.2 subtraction 72.5. Right? You take one to the other side, here 7. 12 minus 5, right? 12 minus 5 is equal to 7. Then here 8 subtraction 2 is equal to 6. Then 32 subtraction 7. So, we'll take here 112. 12 subtraction 7 is equal to 5. Then here 2. Once again, we'll recheck. Here you take 12 subtraction 5 is equal to 7. 8 subtraction 2 is equal to 6. Take one to the other side, 12 subtraction 7, once again 5, then 2. 256.7. Then the final one, 298.2. Subtract 72.5. We'll get the answer now. So, here 12 subtraction 5 is equal to 7. Then here 7 subtraction 2 is equal to 5. Then here 9 subtraction 7 is equal to 2, then 2. Once again, we'll recheck. Here you take 12 subtraction 5, 7. 7 subtraction 2, 5. Then here 22 because 29 subtraction 7. So, 225.7 is the answer. 225.7. Now it's time to get the mass upon volume ratio. So, here I'll take the slide somewhat up. Then we'll do the division, my dear children. First of all, you have to take 247.1 divided by 250. So, here 9, you multiply 0, then 45.54, then 18, 22. So, here 22, 0, 5, 22, make the subtraction, 1, 2, 2, 0, you put the decimal then, right? So, here it should be here because you took the decimal one, so it should be over here. Now, for 2210, there are like 8 2000, 210 is the remainder, once again 0, once again 8. So when you round it off, it is equal to 0.99, 0.99, right, 0.99 then. 0.99, the first one. Then the second one. So here 256.7 should be divided by 250, right? We'll divide. $256.7 by 250. Here 1, 250, 67, 0, 670. There is around 2, 500, 170. Then for 1200, there is like 1700, right? For 1700, 250 times 4, 5, right? 5, 6, yes, there's 6. So 6 times 250, you know that 250 times 4 is equal to 1000, another 2, so 1500. Remainder is 200, right? You put 0 if you want, right? Then you divide and get the answer. So exactly there are 8, right? There are 8. So however, we won't be needing that thing, my dear children. You can round it off and get the answer. So here we are going to round it off to 2 decimal places. So it becomes 1.03. 1.03. So like I said, we won't be needing this thing. So I'll erase so that you might not get confused. Right. So here the third decimal place is 6, my dear children, greater than 5. So when you round it when you are rounding it off, you have to add 1 to the second decimal place. So it becomes 3. 1.03 is the answer. Then 1.03. We'll complete the table. 1.03. 1.03. 1.03. Then the third and the final one, coconut oil. So mass is 225.7. You need to divide by 250. Right? So I'll erase these things. Let's erase. We'll divide the final one and get the answer then. So the final one would be 225.7 need to be divided by 250. So here 0, then for 2257. 2257. Let's see, there is around 2250. We'll multiply and get the answer. It's I think around 9. 0, 45, 5, 4 is the remainder, then 18, 22, 2250. 7 is the remainder, 9. 7 is the remainder. For 70, no. For 700, there is 2, right? There is 2. So once again, we'll recheck. So here there is around 9, right? 2250. So 2250 subtraction. Then 2257 is the answer above. Here 2250. So the remainder is 7. You take 0, then put 0, another 0, then you can put 2, 500. Right, then we'll round off and we'll put the answer. 0.902, 2 is the one, so you can ignore this thing. 0.9 is the answer. 0.90, as it is for the 2 decimal places, will include 0 as well. You know that it's not important to include 0, but however, we have included 2 decimal places in each values, so I have mentioned 90. So these are the values, my dear children, that we obtain from the division process. So as you can see here, for each and every substance, there are different mass over volume ratios. I mean, the densities of the air is getting differed when the substance is getting changed. So like I said in the previous chapter, my dear children, I think that you can remember, when you are dissolving certain things within pure substances, their densities is going to change. Now in the earlier case, can you remember, we took the answer for the density of water as 0.99 in the previous case, when we conducted the activity to get the masses of different volumes of water, and each of those volumes we got the same answer as 0.99 when you take it to the second decimal place, right? So in each of those instances, we could get the same answer because there was no any substance dissolved in it. But however, when you change the substance, or when you dissolve certain things in water, especially like salt or sugar or any kind of a substance which is getting dissolved readily in water, the density is going to change as it is a mixture. So here, we can clearly observe the density in the earlier case was 0.99, but now it has been changed up to 1.03. It's because of the salt contained within the mixture, right, or the solution. So the density of pure substances are getting changed when dissolving certain substances in it. So that's why I told you that density can be used to identify pure and non-pure substances, my dear children. Right. So here, when you take the density of coconut oil, the density of coconut oil is the one which has the least density, right? So salt solution has the highest density. Least density could be observed in coconut oil. Okay. So these are the observations, my dear children. Okay. I hope that you got the idea about the density then, right? Okay. So our conclusion, very simple. You can write that different solutions that means substances, right? Different solutions or different substances have different mass over volume ratio. Within brackets, you can include density. So, different solutions or substances have different mass over volume ratio. That means different density, right? So, from one particular substance to another particular substance, the density is getting changed. Okay, density is getting changed. Right then, so this is the final conclusion that we can come up with the activity. So let's head on to observe the other contents. So here it is given once again, according to this activity, it can be seen that the ratio of mass to its volume is different for different substances, though their volumes are equal. So even though their volumes are equal, my dear children, here we took the same volume, 250 milliliters, even though they have same volume, their mass over volume ratios are going to differ from one to another. Density of various substances differ from each other. It is a specific property of the respective substance. Substances can be identified by the value of their density. So like I said, my dear children, we can identify substances by using the density. We can identify whether the substance is a pure substance or not. Or else if you can measure the density of a certain substance, then we can find out what kind of a substance is it if you know the densities of substances. Okay, actually the densities of normal substances, usual substances that we use, are being calculated and being given in your textbook also. So we'll be head on to those things when we are discussing about the things further with the lesson. Okay, then the next one given, this is common for solids as well as for liquids. So therefore, density is a vital physical quantity of a substance. So not only for the liquids, my dear children, it is common for solids and as well as for the gases as well. But however, we won't be measuring gases. So up to now, you remember that it is a common property for solids and liquids. Okay, for both liquids and solids, it is a common property. You know that gases do not have a specific volume, right? So therefore, measuring the density of gases is somewhat, like it's not relevant, right? So we won't be measuring the exact density of the gases. However, there are some gases that we can include the density. Okay, you just remember those things. So within this lesson part, within this grade 9 syllabus of your science, we'll be discussing about only the densities related to solids and the liquids. Okay, so when you go to further grades and when you're doing your A levels or in like higher studies, you may find out the densities of gas particles as well. Okay, right then, so you remember up to now, within the solids and as well as in liquids, density is a very vital quantity, because you know that we can identify the type of substance by measuring the density. Right then my dear children, so we know that what do you mean by the density. Even we compared the density of different substances as well. Now it's time to do some calculations. So you are given several questions related to density. So first one given, mass of 2 cubic meters of water is 2000 kilogram. Calculate the density of water. So it's very simple, my dear children. You apply the formula rho equal m over v. So mass is given as 2000 kilograms. Volume is given as 2 cubic meters. So when you divide 2000 by 2, it's equal to 1000. This is the usual general density of water, 1000 kilograms per cubic meter. 1000 kilograms per cubic meter. So within 1 cubic meter, it contains 1000 kilograms. For a simple idea, if you take a box like this, box means a cube. When you take a cube like this, okay, and if you can pour water to the topmost level of this container, so here 1 meter, okay, let's take that these are identical. Okay, these are identical. So if these things are identical and if the length of one side is equal to 1 meter, that means, my dear children, if it contains water, then the mass of water is equal to, mass of this water sample is equal to exactly 1000 kilograms. Exactly 1000 kilograms. If you can pour this water into a container and if you can measure the mass of it, then the mass would be exactly 1000 kilograms. This is what do you mean by the density. Mass in unit volume. Here the unit volume is cubic meters. You know that the volume of this thing is equal to 1 into 1 into 1, which is equal to 1 cubic meters. So the volume is 1 cubic meters. Within that volume, there is a mass of 1000 kilograms. That is what do you mean by 1000 kilograms per cubic meter. 1000 kilograms per cubic meter means this thing. So in each and every substance, if you measure the density by using kilograms per cubic meter, this is what does it means. When you pour that liquid or substance into a 1 meter height, 1 meter length, 1 meter breadth kind of a cube, then the mass of that substance is equal to that particular value, okay, which is given within the density. That's what do you mean by the density in simple terms. Right then, so mass of 2 cubic meters of water is 2000. Then we can apply the formula to find out the density. So you divide m and v, then you can get the answer as 1000 kg m minus 3 or kilograms per cubic meter. This is the usual density of pure water, right? Then the next one, the mass of a solution which has the density of 800 kilograms per cubic meter is 200 kilograms. What is the volume of it? So here you need to find out the volume, my dear children. So in that case, what you have to do? In that case, you substitute with the formula rho equal m over v, then substitute the given values for each of these quantities. Then by isolating the term, you can find out the missing one, okay? Here the missing one is volume. So you isolate the volume thing, right? So we'll substitute, my dear children. Density is equal to 800 kg m minus 3. Mass is given as 200 kilograms. Volume we don't know. You know that you can apply the thing called cross multiplication. So I'll put 1 here, then we'll do the cross multiplication. So here 800V is equal to 200. Now divide both sides by 800. 800 to 800 is getting cancelled. 0 to zeros are getting cancelled. Here 2 times 1. Right? Then here 2 times 4. 2 times 1, 2 times 4. When you divide 1 by 4, it is equal to 0.25. 0.25. Now, what is our unit, my dear children? What is our unit? So, these units are given from standard international units. Here, kilograms. Here, kilograms per cubic meter. So, if the density is given as kilograms per cubic meter and the mass by kilograms, then we will receive the unit of volume by cubic meters. It is received by cubic meters, my dear children. Right? It's very simple to identify. Check what is the unit of density, kilograms per cubic meter. Check what is the unit of the mass given, kilogram. So it's very obvious. I can show it to you how it is getting cancelled like this. We know that here 200 is the kilogram value. 800 is the kilograms per cubic meter, kg m minus 3, m to the power negative 3. So kilogram to kilogram is getting cancelled when they are dividing. Then when you take this m to the power negative 3 to the top, it becomes m to the power positive 3. So you divide these two and get the answer then, 0.25. So this is how the cubic meter would come by cancelling off the units. So our answer for the second question would be 0.25 cubic meters, my dear children. 0.25 cubic meters. Right. So this is the answer for the second question then. Okay. Then, my dear children, we'll be discussing a fresh new part in here. This is regarding hydrometers. Hydrometers. So now let's head on to see what kind of a thing is this hydrometer. So here it is given. If you want to find the density of a liquid, so I'll take the slide somewhat up. if you want to find the density of a liquid, you can measure the volume and mass of it and calculate the density as you have done in activity. But it is a time consuming, difficult process. So we completed 2 different tables. I think that we could remember the 2 tables, my dear children. When calculating those things, it was really time consuming one, and we have to do the activities. We have to measure the masses, their volumes, the empty beaker, masses of the empty beakers, then measure in cylinders. Then we have to exactly measure those things by keeping those things in our eye level. I mean, like, when we are doing these things, several several errors may happen, right? So we won't be able to get 100% accurate readings by doing those kinds of activities. So it's very difficult and time consuming process to measure the density by using like activity kind of a process. So in that case, my dear children, we have to use a different kind of an instrument to measure the density. Okay, so here it is given. Therefore, to measure the density of a liquid easily, an equipment known as hydrometer is used. Then we use this hydrometer thing to measure the density of the liquids. Okay, especially for liquids, my dear children. To measure the densities of the liquids, we use the instrument called hydrometer. Hydrometer is made of a thin glass tube, the lower part of which is blown to form a bulb. This bulb is filled with lead shots so that a part of the tube is submerged and float vertically in the liquid. So this is the one which is referred as the hydrometer. This is the structure of hydrometer, my dear children. Hydrometer is made by thin glass tube. The bottom of it is being blown so that it would create a circular bubble-like thing. Within the bubble, in order to make it somewhat heavier, we can observe lead shots or any other masses. Okay, usually we use lead shots. So when you take this hydrometer and dip in a liquid, what will happen? A part will float, right? A part. So if you take, this is the liquid, then this is the hydrometer thing. You dip the hydrometer, then what will happen? The hydrometer, as it is having a greater mass at the bottom, the hydrometer will dip within the liquid and it will vertically float like this. Then by using the scale on the hydrometer, we can measure the density. So this is the way of measuring the density by using the hydrometer. So when you are taking this liquid, you have to take a vessel, right? You have to take a special vessel so that we can insert the hydrometer without touching the bottom of it. If the bottom is touched, then you won't be getting accurate answers. It should be like this. It should be sunk within the liquid and float. And it should float. Okay? It should not touch the bottom of the container. Remember. So when you are taking these containers, you have to take somewhat longer containers like measuring cylinders. Okay? In order to get the density. Right then. So these are the ones which are called as hydrometers, my dear children. Hydrometers. So hydrometers can be used to measure the density of liquids. Right. So when a hydrometer is partially immersed and floating in a liquid, the length of the immersed part depends on the density of the liquid. It sinks less in high density liquids and more in low density liquids. So my dear children, this is very special. It sinks less in high density liquids and more in less denser liquids. So if the density is high, right, if the density is high, then the amount or the level which it going to sink is going to be less. If the density is low, then more amount will sink. Okay. So the upper tabular part of the hydrometer is calibrated in such a way that density can be directly read by the depth it immerses. Okay. So by using the scale on the tabular surface or on the glass sheet like this, you can directly read out the density, right? You can directly read out density from the level that from the final level of the liquid and the particular scale. Okay, so this is how to measure the density of a liquid. So as you can see here, these are three liquids: liquid A, second one is water, and the third one is liquid C. So the liquid A, it has a lesser, I mean like the depth which the hydrometer is going to sink is somewhat less. More part is floating. In water, somewhat greater part than the A has sink, but however, the floating part is somewhat lesser. In liquid C, it's even more lesser. The floating part is even lesser. The sunk part is even greater. So like I said, my dear children, can you remember it sinks less in high density liquid? This is the part which has sunk. This one. In here, this one. In here, this one. So you can see that the part which has sunk in each of the containers is keep getting increased from liquid A to B to C. That means, my dear children, we can say that the density is getting decreased when moving X to Y to Z, or else from liquid A to B to C. So the highest density can be observed in liquid A because less amount of hydrometer is sunk in the liquid. If once again, if the density is high, then less part is going to sink. If the density is low, more part is going to sink. So this one has the highest density. This one has an intermediate density when compared to A and C. And the C liquid has the lowest density because a greater part is sunk within the liquid. So this is the way of measuring the density, my dear children. So to get the count of the density or get the value of the amount of the density, you can use the scale which is printed in here. Then by using the scale, you can directly get the answer like how much is the density. Okay, right. So this is the hydrometer, my dear children, the hydrometer. Right then, my dear children, let's head on to see the next content. It is shown that the same hydrometer is made to float in three different liquids. So as you can see, this is the previous picture, my dear children. The explanation is given, right? So as you can see within the figure, there are three liquids, and the same hydrometer is made to float in three different liquids. The figure B shows how it flows in water. So this is showing how it is going to float in water. Immersed height of the hydrometer is less in liquid A than in water. It indicates that the density of liquid A is higher than that of water. So like I said, my dear children, this liquid has the highest density, this one has the lowest density, this is the intermediate one for the given two liquids. So as less part has been sunk within the liquid and more is floating, this liquid has the highest density among these three. Okay, always go for the part which is floating, or else you can find out using the sinking part as well. But if you are taking the sinking part, then the relationship would be the opposite. That means if more part is sinking within the liquid, then it has a lesser density. If a lesser part is sinking within the liquid, then it has a higher density. So here lesser part is getting sunk, so therefore it has a higher density. The liquid A has higher density. Then the second point, immersed length of the hydrometer is more in liquid C than in water, right? So the density of liquid C is lower than that of water. So here the density is lower than the water, my dear children, because more part has sunk within the liquid C. When you compare it with water, the part which has sunk is even greater than the water. So therefore, liquid C has the lowest density of these three. Okay, right. So if you want to know the value, then you go for the scale over here. Okay, we'll be doing an activity to measure the densities, right, when you go further with the lesson. Right then, so for external edge, you are given with a certain detail. Let's see what is that. The density of the salty water of the Dead Sea located in between Israel and Jordan is very high. It has ability of floating a man without sinking. So as you can see here, this person, even he is not swimming over there. However, you can see that the particular person is not getting sunk within the water. Why is that? Because, my dear children, this sea is referred as the Dead Sea. Why it is referred as the Dead Sea? The name itself refers or gives the idea, Dead Sea. It is dead. Dead means there is no life in it. You know that in normal water, we can identify several organisms like fish, different types of fishes, then octopus, then seahorses, like that. There are different kinds of organisms. But however, my dear children, such animals cannot be observed in Dead Sea. That is why it is referred as the Dead Sea, because there are no any fishes like organisms living within the water. Why is that? Because it has greater salinity. Salinity means high amount of minerals and different kinds of salts dissolved within the liquid. That means it has a very high density. Density is even greater than human beings. So therefore, if you go to Dead Sea and if you don't know how to swim even, you won't be sinking within the Dead Sea, because the water which carries the density, or the water which carries on the Dead Sea, right? The water that observed within the Dead Sea has a density even greater than your density. So therefore, you will easily float in the Dead Sea, right? So it has a very high density. That is why even you can float without sinking, even if you can't swim, right? Okay, right, my dear children. Now, like I said, we are going to use the hydrometer and to measure the density of different liquids. Okay, we are going to use the hydrometer and we are going to measure the density of different liquids. So you are given with an activity, a simple activity, using a hydrometer to measure the density of some common liquids. So what are the liquids that we are going to take? We'll be taking water, then kerosene oil, coconut oil, So these are the three liquids that we are going to use. So like I said, when you are measuring the density by using the hydrometer, my dear children, it's important to take somewhat higher, like the height of the container should be greater, because we have to insert this thing into it and it should not touch the bottom. So we have to take somewhat higher, right, measuring cylinder like this. Okay, so this is a measuring cylinder. Measuring cylinder. Then the next one, hydrometer. Hydrometer, right? The next one is hydrometer. So we are going to insert the hydrometer into each of these liquids and to observe their density. So remember, we have to take a special container like this, so that we need to insert this thing, right? So remember, when you are putting these things into when you are putting these things into the measuring cylinder, you have to dry out the cylinder first and then insert. Okay. So because like I said, if you mix substances together, then the density is going to change. That's the reason. Right, then let's head on to see the method of doing the activity. So the method, it's very simple. What you have to do? Insert each liquid to the measuring cylinder one at a time. One at a time. Then insert the hydrometer and measure the density. Right? So you have to remember, it's important to clean the vessel well, before inserting So here, not only the vessel, my dear children, but make sure to clean the hydrometer as well. Okay, so it's important to clean the vessel, hydrometer before inserting to the liquid. Right. So this is the method. First of all, you have to insert each liquid to the measuring cylinder one at a time. One at a time you have to insert. Okay, that means separately you have to insert one at a time. Insert the hydrometer to the liquid and measure the density. Then you have to insert the hydrometer to the liquid and measure the density. But remember, it's important to clean the vessel and the hydrometer before inserting to the liquid, right? Remember, you have to when you are before inserting the liquid, you have to make sure clean out the hydrometer and also the vessel as well. Right. So this is the method of doing the activity, my dear children. Okay. So now let's head on to the laboratory and we'll do this activity and we'll measure the densities of these three liquids. Okay. And once again, we'll come back to the classroom to write down our conclusion and the observations. So my dear children, now within this activity, we are going to test the density of each, there are several solutions. So we are going to check the density of each and every solution. We are going to take 3 solutions, and from those 3 solutions, we are going to take the density reading separately by using the hydrometer that I have over here. So this is the one which is referred as the hydrometer, my dear children, the hydrometer. So as you can see here, the hydrometer, so within this hydrometer, the largest value is over here, 2.0. And from that, you can see the values of the hydrometer is keep getting decreased up to 0.7 over here. That's the least value. So when the hydrometer is dipped in any kind of a solution, if more amount is getting down, right, if more amount is getting sink within the solution, then the density is less. If more amount is floating on the solution, then the density of that solution is high. So I have with me right now, this is a solution. This is actually water which I have taken from the tap. Okay, so this is normal tap water. So at the end of the hydrometer, as you can see here, right, at the end of the hydrometer, there is some lead shots. These are lead shots, smaller lead shots. So this will allow to sink hydrometer up to a certain level and to float on the solution, right, or the liquid that we are going to insert. So by that way, we will be able to measure the density of that particular solution or the liquid. So now it's time to insert this thing into the water that we have, and let's observe how much is the density of water. Gently we will insert this thing. Right. So I'm going to turn this thing so that you guys can observe it. So as you can see, the density of the solution which I have here over now is nearly 1000. This is, I told you that this is water. So the density of water is 1000. This is given from using the unit kilograms per cubic meter. Kilograms per cubic meter. So as you can see here, it's equal to 1000, right? 1000 kilograms per cubic meter, right? So the density of this water contained within the, so density of water contained within the vessel over here is equal to 1000 kgm minus 3 kilograms per cubic meter, right? 1000. So now my dear children, let's insert kerosene oil as the second solution into the vessel over here, and we'll measure the density of the kerosene oil, and let's check whether the value of whether the density of the kerosene oil that we are going to receive from the measurement is going to tally with the table which is given in your textbook. Okay, so let's go ahead with the kerosene oil and we'll measure the density of kerosene oil now. Right, my dear children. So now I'm going to insert the hydrometer into the kerosene oil over here. Remember, before inserting this thing into the kerosene oil or to any other solution, you need to wipe out this hydrometer very well, because earlier we measured the density of water, no? So we have to remove that water, otherwise your readings will get faulty. So by using a tissue paper, make sure to remove and to wipe out all the liquid which measured earlier. Okay. All right. Now once again I'm going to insert this thing into the kerosene oil solution. Right. So gently I have inserted it into the kerosene oil. So I'll take the reading first, then I can show it to you. So my dear children, now as you can see here, first of all I'm going to take out a reading, then I'm going to show it to you guys as well. So here from the top, remember that the measurement should be taken from the top to bottom. Okay. So the top here it is 700, 7.5 is there. Nearly it is about 7.6, we can say it as 7.6. So 7.6 means in here 760. Okay, as you can see here there is 760. So now I'm going to turn this thing towards you guys. Check it very clearly. It is under 7.6, somewhat under 7.6, but we'll round it off and take it as 7.6. So that means 760. So the density of kerosene oil is nearly 760 kilograms per cubic meter. Okay, 760 kilograms per cubic meter. So as you can see here, the value can be clearly observed. Here it is 700 and here 7.5, somewhat greater than 7.5. So 760. Rounded off value is 760. So 760 kilograms per cubic meter is the density of kerosene oil, my dear children. So let's now head on to the third and the final liquid that we have, that is coconut oil, my dear children. So we'll clean this thing out. So I'm going to take the hydrometer out and we'll clean it, and let's go ahead to measure the density of coconut oil. Okay. So my dear children, this is the third and the final liquid that we have. So this is coconut oil. So once again I'm going to wipe out the kerosene oil which is on the hydrometer that we have. So let's wipe it very well. Right. Then let's insert this thing into the coconut oil and we'll check how much is the density. Nearly 900. Yes, 900. So I'll turn this thing towards your side. Observe it clearly. Here 700. Then here at this level you can observe 900 or 0.9. So 900 is the answer or the value that we have obtained for the density of coconut oil. So this is equal to 900 kg m-3 or kilograms per cubic meter. Okay, for each and every cubic meter the mass of coconut oil is equal to 900 kilograms. Okay, 900 kilograms per each and every cubic meter. So that what's the density means, right? So we took the answer separately for the coconut oil, kerosene oil, and for the normal water, right? So let's head on to the classroom, my dear children, and we'll tabulate our readings then. So my dear children, we conducted the activity and you could clearly observe we measured the density by using the hydrometer in those three liquids quite easily, right? So we use several solutions, right? We use several solutions, right? So within those solutions or within those liquids, we could clearly measure the density by using the hydrometer. So our observation and conclusion are quite simple, my dear children. Observation is very simple. Different right? So we'll write observation like this. hydrometer sinks in different liquids at different levels. Right. So hydrometer sinks in different liquids at different levels, indicating their density. Indicating density. Indicating density on the scale. Right, so the hydrometer sinks in different liquids at different levels, indicating density on the scale. So conclusion is hydrometer can be used to measure the density of liquids, right? So hydrometer can be used to measure the density of liquids. Right, so this is the conclusion. Hydrometer can be used to measure the density of liquids. To measure the density of different liquids, we can use the hydrometer. So my dear children, this is the original hydrometer, right? Can we make a hydrometer at our house? I mean, like a sample of a hydrometer, like a toy hydrometer. Can we do it at the house? Of course you can. So by using a different kind of materials, we can build up a hydrometer at our houses. So by using that toy hydrometer, we can compare the densities also. But however, rather than comparing, my dear children, you have given with a special kind of a table. Within this table, the exact accurate density is being measured in different liquids. So in mercury, the density is like 13,600 kilograms per cubic meter. 13,600. I mean, like you can measure, you can take the toy kind of a hydrometer which we are going to prepare at houses, and you can dip in that, you can dip that thing in different solutions and you can compare the densities. But however, you won't be able to get an accurate answer, right? We'll be even making a toy hydrometer when you move it in, when you go with the next lesson parts. Okay, even we are making that thing in our laboratory, right? But however, you won't be able to get accurate answers, exact values by using that kind of an instrument. So, but however, the hydrometers that I have shown you previously can be used to determine the densities of liquid, because those things are made according to the standards. Okay, so these are several densities of different kinds of liquids, my dear children. Like I said, mercury has density of 13,600 kilograms within 1 cubic meter. Then glycerine, 1,262 kilograms per cubic meter. Milk, 1,030 kilograms per cubic meter. Seawater, 1,025 kilograms per cubic meter. Then water, you know, it's equal to 1,000 kilograms per cubic meter. Olive oil, 920 kilograms per cubic meter. Coconut oil, 900, right? 900 kilograms per cubic meter. Turpentine, 870 kilograms per cubic meter. Petrol 800 kilograms per cubic meter. Liquor 791 kilograms per cubic meter. Then kerosene oil 790 kilograms per cubic meter. So these are densities of different liquids that some common liquids that we can find in our day-to-day life. Okay, so as you can see here, the density of mercury has the highest of them all, which is the 13,600 kilograms per cubic meter. Okay, right. So like I said, my dear children, we can even make toy hydrometers. By using these things, we can by using this toy hydrometer, we can compare the density, right? We can compare the density of different liquids. But mainly, we'll be using these liquids: coconut oil, salt solution, and normal water. We can use, I'll be preparing this hydrometer to compare the densities of these liquids. Okay, so let's see how to make this toy hydrometer. First of all, we'll check what are the materials that we need. First thing, you'll be needing a straw, a plastic straw. Then some candle wax. Some candle wax. So we'll be using this candle wax in order to seal out, right? Then bicycle balls. Bicycle balls are used instead of lead shots, my dear children, right? We can insert these bicycle balls to the straw from one end and we can seal it down. Then we can insert this thing on the liquid and it behaves as a prototype hydrometer. Okay. Then a measuring cylinder. You know that we'll be needing a measuring cylinder for sure to measure the density. Right. Measuring cylinder. Then the three liquids: coconut oil, salt solution, then here water, normal water. Right. So these are the materials that you need, my dear children. So let's head on to observe how to conduct this activity. Okay. So the method: heat one end of the drinking straw in the candle flame to seal it. So you can even use the candle flame, but be very careful. If you heat it too much, then the plastic would melt and you won't be able to do it. So I think it's better to insert candle wax in order to seal it well. Okay, right. So here it is given: heat one end of the drinking straw in the candle flame to seal it. Add enough water to the density jar or the measuring cylinder. Put iron balls into the straw so that it floats vertically while 2/3 of its length is immersed in water. Mark the floating level on the straw while it is in water. Now you have finished making the hydrometer. So what you have to do? You have to seal one end. Then at the other end, you have to insert several bicycle balls. If the bicycle balls are falling down, then you can seal that end too by using wax or by heating the straw. Okay. Then what you have to do, my dear children? You have to first of all take the measuring cylinder. Then you have to add water so that remember that when you are adding water, add somewhat more, because when you are going to insert that thing, it should float. It should never touch the bottom or the other surfaces. Okay. So you have to add water to the measuring cylinder. Then you have to insert that instrument or the hydrometer which you have prepared into that container. Remember that at least 2/3 of the length should be immersed in water, right? at least 2/3 of the one or of the instrument or the straw should be immersed in water, while the other one should, while the other part is floating. Okay, the remaining 1/3 part should float on water. Okay, more part should be immersed in it, right? That's how we use the hydrometer. Then the other thing is that it should be in a vertical position, right? It should be in a vertical position, my dear children. That means, let's imagine that it's like this. This is my measuring cylinder. Okay, if this is the measuring cylinder, this is the liquid level. It should not be like this. It should not be like this. Sometimes it might be like this. So it should not be like this, my dear children. Remember. Okay. It should not touch the surface, or it should not be like this, a slanted kind of a way. It should be vertical. Should be very vertical like this. This is the way. Okay, should be very vertical like this. So remember to keep it vertical. If it is not vertical, I mean it is getting slanted, then you have to add more mass to the bottom so that it would float vertically. Okay, right. So here, let's see the other point then. Add salt water into the measuring cylinder and float the hydrometer in it. Mark the level of floating on the hydrometer. Now in the earlier case, you have to add water and mark the particular level. Then the next one, you have to add the common salt solution. Then you have to mark the level. Then in the third one, repeat the above step using coconut oil as the liquid. So in 3 different liquids, we are going to measure the density, not actually, right? We are just going to mark the level, right, which the hydrometer is going to float. Decide whether the density of liquids used is higher or lower than that of water according to the levels of floating. So according to the floating levels, we can compare the densities of liquids, my dear children. Okay, right. So this is the way of doing the activity, my dear children. So let's head on to the laboratory. We'll make this toy hydrometer or the prototype hydrometer. Then we'll insert the hydrometer into those 3 liquids and we'll compare the densities. Okay. Then we'll come back to the classroom to write down our observation and conclusions. So my dear children, within this activity, we'll be making a prototype of a hydrometer. So this is the hydrometer that I have used earlier to measure the densities of different liquids. So you know that we measured the density of kerosene oil, coconut oil and water by using the hydrometer. Like I said in the earlier, the bottom corner of the hydrometer is firmly filled with lead shots, and by putting out some amount of wax, it's been sealed. As you can see, those things are not coming out. So when you dip this thing in a solution, it will float and the reading will allow you to take the necessary amount. Okay, so amount means the necessary reading of the density. So now we are going to make a prototype hydrometer which is going to be same as this thing. So in making this prototype hydrometer, I have with me a straw, a plastic straw and several bicycle balls. Okay, so what I'm going to do is, so I'll keep this thing away safely. Right. So what I'm going to do here is, I'm going to insert these bicycle balls into our tube like this. Okay, you need to insert the bicycle balls into our tube or to the straw like this, and insert that straw onto the liquid and observe whether it is getting sink like up to two-thirds of the size or the level of the tube over here. At least it should sink up to two-thirds of the level. So by that way it will freely flow within the water. Now as you can see here, by inserting 1, it will not float like in the previous case. So as you can see, it's now been bent to a certain direction. So that means we need to increase the weight below it. So now let's insert another one like this. Okay, so let's insert another one like this and we'll check now what's going to happen. Now it's okay, right? So like that way you need to prepare a hydrometer, a simple hydrometer like this. So it should be held vertical like this, and like up to two-thirds of the level of the straw should be underneath the solution. So I'm going to take this thing out now. Okay, I have prepared a special kind of a prototype hydrometer with me. So I'm going to take that thing. So here, this is that prototype one. Here my dear children, now in the earlier case I have inserted only 2, no? So now here there are 3 bicycle balls inserted into the straw, and straw being cut out from a certain height. So if you want, you can cut it out, but here we are going to compare the density values of water compared with the kerosene oil and other different kinds of solutions. Okay, so now let's insert and get a reading from normal water. Now you can see that two-thirds of the hydrometer or the straw is getting into the liquid. Two-thirds is now sunk within the liquid. So now what do you have to do, my dear children? We'll mark out the level, right? So we'll mark out the level. I'll insert the finger and I'm going to mark out the level of it. Okay, it's about this level. About this level. So I'm going to insert once more. Right. So the marker is somewhat below. So I have to recheck it. So I need to mark the level. Exactly, I'm going to mark the level, my dear children, right? So I'm going to mark this level, okay, by using a marker pen. I'm going to mark it down. So this is the marker pen. I'm marking it out now. Right, now let's insert it once more and see whether our mark is correct or not. Right. Now as you can see here, our marker is now at the same level as the water. See? You can observe it very clearly. This is the hydrometer which I have prepared by using the straw. So it has the same level like this, see, as the water, right? Okay, now I'm going to take this out and let's dip it in a different solution like kerosene oil or coconut oil or any other different kind of a solution. Okay, and let's observe what is the density of that particular liquid compared to the density of water over here, whether the density is high or whether the density is lower than this thing. Okay, Right, so we'll use a different solution and we'll observe what is going to happen with the density compared to the water. So my dear children, this is the second solution. So this is salt solution, okay, common salt solution. So like we discussed, my dear children, you know that when dissolving certain things, especially solids in water, you know that the density is going to change somewhat. Especially when you are dissolving solid substance within water, the density of the water is going to increase. Density of the water is going to increase, my dear children. So in the earlier case, we prepared a special hydrometer and this was the level, right? This was the level of water, right? This was the level of water. Now within water, this hydrometer sank up to this much of a height. Okay. So now I am going to insert it into this particular salt solution and we are going to observe what is the level or up to which level does the salt solution is going to sink this hydrometer. Okay, so if the salt solution is going to sink this hydrometer greater than the marked level, I mean like if more amount is going to sink within the liquid or within the salt solution, then we can say that compared to the water, compared to the density of water, salt solution is having a lesser density. Okay, it is having a lesser density. Why it is having a lesser density? Because more amount is getting sink within the liquid. If more amount is getting sink within the liquid, then the density is less. If more amount is floating on the liquid, then the density is high. Okay, so up to this level, right, up to this particular level, water, right, up to this particular level, water sink the, right, or water has sunk the hydrometer which I have prepared over here. Now let's insert into the sodium chloride or common salt solution and we'll observe like to which kind of a level, right, like up to what kind of a level does this sodium chloride solution is going to sink this hydrometer. So let's insert and observe. Right, as you can see, it's very clear to us that earlier it was up to this level, but however now the level has been reduced. Somewhat lesser amount is going to sink within the sodium chloride solution, my dear children. If less amount of hydrometer is going to sink within the sodium chloride solution, then we can say that the density of sodium chloride or density of common salt solution is greater than that of water. That's why there is a clear difference between the two levels. In water, like 1 centimeter of a height, like up to 1 centimeter, right? Yes, like up to half of a centimeter, not just one, half of a centimeter to a height, right? There is a difference between like half of a centimeter, right? So half centimeter is greater in normal water, the length which has sunk within the liquid. Okay, half centimeter is more than, like half centimeter more than this level is going to sink within the normal water. But however, in sodium chloride, half centimeter is lesser than the initial. Okay, so by that way we can say that, okay, by that way we can say that we can conclude that density of sodium chloride solution or common salt solution is greater than that of water, right? Right then, so let's see the density of another solution, okay, compared to the density of water. So we'll use another solution and we'll observe the density then. Right, so this is the third solution that we have, my dear children. Okay, so by the looks of it, you know that this is coconut oil. So I'm going to insert the hydrometer which I have prepared into the coconut oil and let's see whether the level is going beyond this level or above. Okay, so if more amount is going to sink, then we can say that the density is less. If less amount is going to sink, then the density is high. Okay, so you know that coconut oil having a lesser density than water, so it should go beyond this level. So we'll see whether it is going or not. Yes, as you can see, it's very clear to us that it is going beyond the level, right? So here, in here you can observe the initial level, that was the level of water. Now it is very clear to us that the density of coconut oil is lesser than the density of water. That's why more amount is going to sink within the liquid. Okay, so this is the comparison of the densities of these liquids, right, compared with the water, my dear children. So we discussed the comparison of two different liquids. Okay, first we took coconut oil, first we took salt solution, then we took coconut oil. Salt solution had a greater density than the water, and coconut oil as you can see, it is having a lesser density than water. More amount of hydrometer is going to sink within the coconut oil. However, less amount of hydrometer is going, or less length of hydrometer is going to sink within the salt solution, right? So our benchmark was the level at water. Okay, the length of, or the sink level at water was our benchmark. So compared to the benchmark, or compared to the water level, right? So this is having a greater length. That means the density is low. The previous one was having a lesser length. That means the density was high. So now let's head on to the classroom and we'll observe what are the other things contained in the lesson part. So my dear children, we conducted the activity and we prepared that toy hydrometer. So you could clearly observe that the floating levels are different from one particular liquid to another, right? So we have compared the density by taking the benchmark as water, and we could clearly find out whether the when we are comparing the density of water with the other substance. We'll take coconut oil. What is going to happen with the coconut oil? Okay, then when you are comparing the density with the other one, the salt water, what has happened to the density when we are comparing density of water with the common salt solution? So you could clearly observe that common salt solution had the highest density, then coconut oil had the lowest density. Less part, okay, very less part was floating in coconut oil, but however greater part was floating in salt water. If you compare the immersed part, then more part has been immersed, or more part was sunk in coconut oil. Okay, but however less part was sunk in common salt solution, right? So by that way we can compare the density of water, density of other two substances compared to water, right? So we'll write down our observation then. More part of the hydrometer sunk in coconut oil, right? more part of the hydrometer sunk in coconut oil. Then less part of the hydrometer sunk in soil solution. So therefore, we can write down the conclusion, the final conclusion, my dear children. What is our final conclusion then? Number 1, coconut oil has lower density than water. Right? Coconut oil, right? Coconut oil has lower density than water, Then number 2, salt solution has higher density than water. Right? So coconut oil has lower density than water, then salt solution has higher density than water. So these are the 2 conclusions, my dear children, right? The 2 conclusions. Right. So the observation, more part of the hydrometer sunk in coconut oil, less part of the hydrometer sunk in salt solution. Then conclusion was very simple, coconut oil has lower density than water. However, salt solution had the higher density than water, my dear children. So this is our conclusion from the activity, right? Right then, so from that activity, my dear children, I'm going to finish up the second chapter, right? I'm going to finish up the second chapter. So within this chapter, we discuss several further things regarding the density. Even we compared the density of different liquids, right? By using their values. Okay, we found out experimental values for the density of different substances. Even we measured the density by using the hydrometer thing, right? And we have even prepared a small bit of a hydrometer to compare the density of different common liquids that we can find in our day-to-day life. So my dear children, within the third chapter, we'll be discussing further things related to these hydrometers. Especially, we'll be discussing about the users of hydrometers. Then, my dear children, like in the previous chapters or like in the previous lessons, we'll be discussing several questions related to the 11th density lesson. Okay, right then. So I'll be winding up this chapter. I hope to discuss users of hydrometers and other things related to the lesson in the third chapter.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.